What if all our theories, from the Big Bang to the fundamental truths about our universe, turned out to be wrong? For years, the basic principles of modern cosmology and the fundamental laws of physics have served as reliable beacons in our understanding of the universe. But since the beginning of the James Webb Telescope, its discoveries have caused us to question our previous principles. Is it time to rethink our picture of the universe? Or are we facing distortions in the data? Let's go back to July 2023. NASA presented the world with startling images of ancient galaxies. The age of these galaxies was such that their existence seemed absurd even on the cosmic periphery. Scientists around the world checked the results and came to a unified conclusion: these galaxies are real and no anomaly exists. They existed when the universe was only about 350 million years old. That's what became the scientific problem. Not only are these galaxies old, but they are incredibly massive and complex. Their brightness surpasses even the most radiant galaxies of our time. But the big problem is that during this epoch of the universe, according to previous calculations, only the first prototypes of galaxies existed. Scientists envisioned it roughly as follows: between 200 and 400 million years after the Big Bang, the first stars came together, from which galaxies later evolved. So they expected to find galaxies in the new James Webb Telescope images that are either small, chaotic, or dark. But what happened changed their understanding. If we believed for a century in a theory that turned out to be wrong, now it was time to clean it up and find out the truth. First, the researchers checked all the redshift values. Astronomers have used this value to measure extremely large distances in space. Light traveling for billions of years changes its wavelength, as if stretched across time and space. The larger the redshift value, the farther away the objects emitting the light are, and the older those objects are. So, simply put, this means that redshift is a measure of distance. By joining forces, the world's best telescopes have confirmed the amazing. James Webb saw an absolutely true picture. Those distant galaxies with a redshift of 16-20Z really do exist, defying everything we knew up to that point. And while Webb's telescope is one of the largest, its 6.5 meter 21.3 feet lens diameter doesn't allow for the clarity needed. After all, there are telescopes with diameters of 10 and even 12 meters. But even this may not be enough. For this reason, a new telescope with a lens diameter of astronomical 40 meters 131 feet, which is larger than a basketball court, is being developed. It's called the Extremely Large Telescope, ELT. The telescope should be ready for operation in 2028. Such an eye can gather much more light, allowing us to do a deeper spectral analysis. Another point concerns the centers of these galaxies, where we are already finding evidence of massive black holes. Here we face another conundrum. According to the standard scenario, black holes form from the remnants of supernovae, stars that have completed their life cycle. These objects typically have masses between 10 and 30 solar masses. However, in the centers of galaxies, we find black holes with masses in the millions and even billions of solar masses. Existing theories are difficult to apply to explain such sizes. One possible answer lies in the role of black holes in the process of galaxy formation. These massive black holes play a key role in the accelerated formation of galaxies, activating star formation processes, or even representing the primary seeds from which galaxies begin to grow. Interestingly, their potential impact may not be limited to the scale of individual galaxies. Traditionally, this acceleration was thought to be caused by dark energy, an unknown form of energy that has negative spacetime curvature. However, recent observations have challenged this theory. In 2022, astronomers discovered that supermassive black holes at the centers of galaxies may also be contributing to the expansion of the universe by creating gravitational waves. These waves propagate through spacetime and create pressure that pushes galaxies away from each other. Gravitational waves are fluctuations in spacetime that propagate at the speed of light. They can be caused by a variety of phenomena, including black hole collisions, supernova explosions, and other gravitational events. In the case of black holes in the centers of galaxies, gravitational waves are created by the rotation of these black holes, and have masses that far exceed the mass required for them to form from the remnants of supernovae. This means that these black holes must have formed by other processes, such as the merger of smaller black holes. They are surrounded by clouds of hot gas and dust that rotate around them at tremendous speeds. This rotation creates a transverse component of gravitational waves that pushes galaxies away from each other. If this theory proves to be correct, it would mean that the universe has no end and will continue to expand forever. It would also mean that dark energy is not the only factor contributing to the expansion of the universe. The end for the Big Bang? The Big Bang is thought to have been the starting point of the universe 13.8 billion years ago. Using known quantities from physics and astronomy, the researchers reconstructed how the young universe evolved from that initial event. Of course, things in space don't have to be right just because they can be calculated. Mathematics and astrophysics are still far from being able to describe all phenomena. For example, Einstein was unable to mathematically reconstruct the existence of the entire cosmos. Nevertheless, many of his computational predictions were consistent. But he only knew about the existence of black holes from math and physics long before they were actually discovered. The Big Bang theory was 100% consistent with pretty irrefutable physical quantities from Einstein's theories of relativity. But now these 6 galaxies are blowing a hole in the old picture. There's more to come. The waves around the 6 impossible galaxies had barely had time to subside when NASA's Twitter post shook conservative branches of the natural sciences once again. A cluster of galaxies with 7 galaxies was found to have a redshift of 7.9. Thus, the cluster existed only 650 million years after the Big Bang. For all the scientists who until this point had hoped that the new real discoveries could be due to a possible error, it was again a shock. Galaxy clusters are clusters of single galaxies. The fact that such formations already existed 650 million years after the Big Bang further proves that the cosmos is already a teenager in its supposedly infantile days. What does this mean for our worldview and cosmology? First of all, we must realize that the Big Bang theory has never been proven. Although many thought otherwise, the theory worked mathematically, but it also left questions open. Therefore, it could never say for sure, why did our universe come into existence? What came before it? Is the universe finite or infinite? Or what was the starting point? In principle, the Big Bang theory even violates another very important law of physics. The second law of thermodynamics states that in a closed system, disorder tends to increase. If the universe emerged from an initially highly ordered state, as the Big Bang suggests, then this contradicts this law, as it requires evolution toward greater disorder. If the Big Bang theory turns out to be wrong, it by no means means that all physical quantities